Hello everyone, welcome to 𝐂𝐤𝐬𝐿. My name is Venkatrao. I am discussing about compiler design. So today is our lecture number 4 in compiler design subject. So before going to start this subject, let us see what we have studied in previous lectures. Hello everyone, how are you? Welcome to the subject of compiler design. For GATE point of view, we are discussing compiler design subject, GATE point of view from computer science branch. Good afternoon, everyone. How are you all? Welcome to 𝐂𝐤𝐿 and welcome to compiler design subject. Right. So, in our last 3 classes, we have discussed about what is a compiler, how to design a compiler, what are the different phases available in compiler. So, how to design a compiler, because we are designing compilers. That too not in programming point of view. We are discussing about theoretical aspect of compiler, how to design a compiler. To design a compiler, what theories, what theoretical concepts are involved inside a compiler. This is what our discussion is going on. So before going to start the actual session of today's, let me just recap what we have studied in previous lectures. Okay. Today is our lecture number 4. We are discussing, today's session is LL1 parsing. Okay. Before that, what we have studied in our previous classes. I hope everyone is comfortable with the previous revision and previous topics, all these things, because today's class also on parsing, syntax analysis. So in today also we are discussing about syntax analysis of a compiler. Right. So what we have discussed in our previous classes. First, in the first class, we have discussed about lexical analysis of a compiler. Lexical analysis program of a compiler, and in this lexical analysis, what we have discussed in the lexical analysis, mainly we discussed about 2 things. One is called as tokens. What are tokens? In lexical analysis, how tokens will be produced, and next one is what is a lexical error. The error detected by lexical analysis is called as lexical error. So how lexical errors will be detected by compilers. So these things we have discussed in the first class. Then in the next class we have started syntax analysis. We can say this is our first lecture. You can say A and B are the topics here. In our second lecture, we are discussing about syntax analysis. In the syntax analysis, we discussed about grammars and ambiguous grammars. We discussed about what is a grammar and what is ambiguous grammar. Ambiguous grammar, and what are the first and follow set of grammar. So what we are discussing in today's class is, what we are discussing in today's lecture. Today's lecture is all about completely on designing of parser. So we are discussing about last class also we discussed about first and follow set, first set calculation, follow set calculation. This is already completed in the last class. Today also we want the help of first set and follow set values. So based on the help of first and follow set values, we are discussing a special type of parser, a top-down parser called as LL1 parser. So today's discussion is completely on top-down parser. So this is what today's agenda. What are the topics we are discussing in today's lecture, right? So let us start. This is one of the easiest topic. This is not a difficult one. So if we are comfortable with first and follow set values calculation, nothing is there. It's very simple topic. Discussing about top-down parser, right? Let us go and discuss about the top-down parser. Before that, what is so we are in the design of second one, syntax analysis. What are the inputs of syntax analysis? Inputs of syntax analysis we already discussed, that is tokens. What is the output of syntax analyzer? The output of syntax analyzer is parse tree. So syntax analysis takes tokens as input, produces parse tree as output, and it verifies syntax. If any mistakes in the syntax, then it produces syntax errors. It generates syntax errors. So in today's class, how to design this program, syntax analyzer, this is also called as parser. By using a top-down parsing method, that too in LL1 parsing method. Okay, right. So first of all, what is parser? If you want to define the parser exactly, the parser is nothing but a program. It takes tokens and context-free grammars as input, both tokens and context-free grammars as input, and verifies tokens are members of context-free grammar or not, or syntactically properly there or not there. So syntax analysis verification is going on. That's why this is called as syntax analysis. Tokens membership is called as parsing. That's why this program also called as parser. Like this, two names are there for this syntax analyzer. One is syntax analyzer, second one is called as parser. So name of this program is like this. So output of this one is parse tree for valid syntax. If invalid syntax, it generates syntax error as a output. So in today's class, we have two algorithms here to design this parser. Let us see what are the algorithms which are available. And in today's class, we are going to discuss about one of that algorithm. Okay. So to discuss about this, we have two type of algorithms called as top-down parsing algorithms. This parser is called as top-down parser, and bottom-up parsing algorithms, this parser is called as bottom-up parser. So to design our parser, to design a parser or syntax analyzer, mainly we have two type of programs. One is top-down parser, second one is bottom-up parser. Like this, we have two type of programs. What is the difference here? Why two type of programs? So the way of construction of parse trees, the way of verification of syntax is different from parser to parser. There are so many advantages, disadvantages in a top-down parser and bottom-up parser. If we use a top-down parser, if we use top-down parsing algorithms, we can design parser in a easiest manner, in a very easy way. But this type of parsing suitable for few languages, not for large class of languages. So we cannot perform much syntax analysis for large class of languages. But bottom-up parsers are more powerful parsers. This is suitable for almost all languages of the world class. That's why if you use a bottom-up parser, it is somewhat difficult to construct the parser. Okay, but it can handle large class of languages. That's why if you observe top-down parser and bottom-up parsers are more powerful than top-down parsers. Top-down parsers are less powerful compared to bottom-up parsers. That's why the major difference is these are more powerful than top-down parsers. Bottom-up parsers are more powerful. So most of the times, even in GATE questions, we can expect majority of the questions from bottom-up parser. In our discussion also, 2 to 3 classes we are spending on bottom-up parser. Learning time also, we may feel little bit of complexity. The designing time will feel little bit of complexity because they are more powerful, handling so many languages. That's why that common thing, complexity is there. But top-down parsers are very easy. And it is easy to construct. Okay. Let us first, before designing this, let us try to see the exact differences between top-down parser and bottom-up parser. So power-wise, more powerful than top-down parser. This is less powerful than top-down parser. And here, tree construction also different. So I'll show you now how to construct the trees. In top-down parser, if it is a top-down parser, a parser is created. One difference is power. The major differences in top-down parser and bottom-up parser is, one is bottom-up parser is powerful, top-down parser is less powerful. And the second difference is tree construction. Top-down parser constructs tree, starts at the root, top to bottom. And bottom-up parser constructs the tree, starts at the string, proceeds bottom to top. So tree construction also one more difference. So the second difference is, here we can see three differences here between top-down parser and bottom-up parser. One difference is tree construction. One is a powerful one anyhow. First one is a power. Power-wise, bottom-up this is more powerful, this is less powerful. Second difference is tree construction. Top-down parsers starts at the top, that is starting symbol, going till the string. And bottom-up parser starts at the bottom, goes to the top. The meaning itself saying top to bottom, top-down parser, bottom-up to top, bottom-up parser. Okay, right. Next one is derivations. In a grammar class we discussed there are two varieties of derivations, leftmost derivation, rightmost derivation. If you use top-down parsers uses leftmost derivation. If you go for top-down parser uses leftmost derivation, whereas bottom-up parser uses rightmost derivation, but actually we'll say in reverse order, it is not exactly same, in reverse order. So this is one more difference. Like this, we have two type of parsing algorithms, top-down parsing algorithms, bottom-up parsing algorithms, as shown previously in the diagram. What is the major difference? There is a lot of difference in these two. So if we go for the first difference, power wise, power means number of grammars suitable. Top-down parser less powerful, bottom-up parser more powerful. That is the first difference. Second one is way of construction of parse tree. Way of construction of parse tree also different in both of this. If we go for top-down parsers, tree construction starts at the root, proceeds to the bottom. If we go for bottom-up parser starts at the bottom, goes towards the starting symbol. Tree construction top to bottom, bottom to top. Difference. Third one is derivations. Derivation also different. So whenever we are constructing any tree, we will use generally derivation, whether it may be leftmost derivation or rightmost derivation. That is also different here. That is not same for the both. If you are using top-down parser, leftmost derivation is used. If you are using bottom-up parser, rightmost derivation is used. Okay. This is the major difference available out of available algorithms. So different between top-down and bottom-up parsing. So like this, we have majorly two varieties of parsing. In today's class, we will discuss about construction of parser by using our top-down approach. Right. Just go through this. If you have any doubts up to this, you can ask me. Right. So in top-down parser, majorly we have two type of algorithms. Recursive descent. Let us focus only on top-down in today's class. Recursive descent parser, LL1 parser. Recursive descent parser, LL1 parser. So our discussion will be mostly on LL1 parser today. Out of these two, out of recursive descent and LL1 is the best parser in top-down. It's most powerful and best parser. So most of the compilers, if we are designing by top-down approach, so to accept large class of grammars, LL1 parser is the best one. So both are top-down approach. Okay. First, let us see how this top-down approach is happening. And this recursive descent parsers generally working based on backtracking approach. So there is a drawback of huge time complexities. That's why they are not much suitable for practical purpose. The time complexities of these, it can goes to its 2 power n like this. Parser may fall into backtracking. So backtracking whenever is there, the backtracking have a drawback of exponential time complexities. So to avoid this, generally without backtracking parsers, LL1 parsers are preferred to design parser in top-down approach. Right. First of all, let us see what is this top-down parser. What is the working style of the top-down parser? This is one of the grammar. What is parsing here? Parsing is one simple thing. We have a grammar, we have an input. That input string is member of given grammar or not. Assume we have a grammar here. This is one of the grammar. Parsing is very small thing. Parsing means don't think it is a very bigger concept. It is very difficult to understand. Nothing like that. Parsing is very simple thing. What is parsing? If I have a grammar, assume I have an input. I have a grammar. I have an input. Verifying a given grammar and given input. The input is generated from given grammar or not. This input is member of this grammar or not, generated from grammar or not. In order to verify this, we have two approaches. Top down approach, different way of verification. Bottom up approach, different way of verification. So today we are focusing on only top down approach. So in top down approach, what we are doing generally, very simple thing. We'll start from the starting symbol. We'll try to generate the string. Start at the starting symbol, try to generate the string by keeping leftmost derivations, by using leftmost derivations. Let us perform top-down parsing manually on this input. So I want to verify this is generated from this grammar or not. So start at the starting symbol, E, starting symbol of the grammar. So what is the leftmost derivation here? Every non-terminal replaced by its right side. So if we have E, E will be replaced by T, E dash, T, E dash. Then leftmost derivation, so leftmost expansions we have to do. So then every non-terminal replaced by right side. This is the way. E will be replaced by right side, T will be replaced by right side, F will be replaced by non-terminal replaced by its right side. That is what happening here. So T is replaced by F, T dash. F is replaced by A. Then T dash replaced by epsilon. Right, T dash will be replaced by epsilon. For this, whenever we have two productions, I am giving sometimes priority for something, sometimes priority for something. This is the exactly where the concept of backtracking involves. So what is backtracking? If multiple productions are there, if a non-terminal having multiple productions, if you don't have any mechanism to select the which production to be used for replacement. So here I am using second one. I am using some mechanism. If you don't have that mechanism, parser will fall into backtracking. Because you don't know whether first one or second one, go with the first possibility. If string is not generated, take the second option, take the third option. Like this, parser continuously will come back and will verify, will come back, will verify. This is called as backtracking. So backtracking, that's why requires lot of time. So in today's class, we are not concentrating much on backtracking. LL1 parsers are without backtracking parsers. So first I'm selecting epsilon here. E dash. E dash also having multiple productions. The normal parsers will fall into backtracking, but whereas LL1 will select appropriate production. There are some mechanisms we'll see now. By using some appropriate mechanism, it will select the correct production. So E dash will be replaced by first one plus T dash. See, top down parser starting at the starting symbol, going like this. Then T is replaced by F T dash. F is replaced by A. So now you can observe the leaves A plus this T dash is replaced by star F T dash. F is replaced by A. T dash star F T dash. This is replaced by epsilon. This is replaced by epsilon. Now T to F T dash. Read all leaf nodes. If you observe all leaf nodes, this is A. Epsilon anyhow no need. Plus A star A epsilon epsilon. So A plus A star A. This is. So how the tree structure, this is called as our parse tree. The parse tree is constructed for any top-down parser. Parse tree is constructed in this way. Starting at the root node, starting symbol, going towards the string. The tree structure is constructed. If any parser constructing tree structure in this way, that parser is called as top-down parser. Top-down parser. In this, we have two different mechanisms: backtracking parsers, without backtracking parser. If it is a backtracking parser, whenever a non-terminal having multiple productions, we don't have any mechanism to predict the right exact correct production. In backtracking, we don't have. But whereas LL1 is predictive parser. That's why the name of LL1 parser is also called as predictive parser. So in predictive parser, I think previously we discussed about this. We have two mechanisms here. So backtracking parser, predictive parser. Predictive parser is our LL1 parser. In LL1, we have a mechanism. If a non-terminal having multiple productions, to select the exact correct production. So let us discuss about this. Backtrackings are not suitable for practical, because practical parsers, if you design by using backtracking, every time going back, exponential time, it may leads to exponential time complexities. Whereas predictive parser time complexity is order of n. Backtracking time complexity order of 2 power n. That's why the best one is order of n. That's why we are going with today, where our discussion will be on LL1 parsing. So let us discuss LL1 parsing. LL1 parsing. The general structure of LL1 parsing is like this. It is a push-down automata concept. Simply, if whenever you are comparing with the theory of computation, simply push-down automata. Whatever the token sequence which are coming from lexical analyzer, all the tokens will be placed in the input buffer. These are the tokens. All the tokens are arranged here. To perform syntax analysis, the token list will be arranged here, and we have a stack. A stack data structure is taken here, and we'll perform push pop operations with the stack. Okay. Like this, for the previous example, we have a small one. What is the concept of thing here? Assume we are performing push pop operations and we are verifying the syntax. Assume we have a non-terminal on the stack. And the input is A. Now on this A on A, if a non-terminal having multiple productions, like this, A is having multiple productions, which production to be used? This is the most critical concept in top-down parsers. Most difficult concept in, if a non-terminal having multiple production, so that non-terminal is replaced by which one? First or second or third? In order to decide this, parser confuses a lot. Here, to handle that situation, we have a table. Name of the table is LL1 parsing table. LL1 parsing table. So the table will handle this situation. Okay. So the table is generally like this. For this type of grammars, we have a table of this kind. So whenever a confusion comes to the parser, whenever the non-terminal, in the tree construction, we observed already, whenever you are constructing tree, if we have a T dash, multiple things are there. So which one? First one or second one? Whenever it comes to confusion, E dash, whenever we are replacing E dash by its right side, multiple things, first one or second one. Whenever this decision taking situation comes, parser immediately goes and observes from the table. Whenever it want to takes the decision regarding selection of the production, it depends on the table. So whenever parser has to predict any production depends on the table. That's why this table is also called as predictive parsing table, used for prediction of particular production from multiple productions. So LL1 parsing table or predictive parsing table is used in order to avoid the confusion, multiple productions confusion. Okay, so to run this algorithm, LL1 parsing algorithm, the first and foremost thing is we need to construct the table according to the given grammar productions. So once the table is ready, once the table is constructed, then running the algorithm and performing syntax analysis, token sequence is proper or not, very much easy. That's why what we have to do here is, for the corresponding given grammars, for the given grammars, how to construct this table. This table is nothing but simply rows and columns concept, arrangement of all the productions in a matrix format. So first in today's class, we'll discuss about the construction of the parsing table. So table construction is the only concept which is very important for GATE exam. In every, almost in alternative GATE exams, we'll get these type of questions. Even in last year, 2024 GATE also, we have one question from this. There are so many questions, possibilities from the construction of table. So in parsings, for GATE point of view, what is the main important thing is construction of tables. We have similar tables in the bottom of parser also. There also table construction is the main important. Let us focus in today's class in construction of LL1 parsing tables. How to construct LL1 parsing table for the given grammar productions. This is a rough example table. So I'm not constructing it. I'm not showing you how to construct exactly. Productions, whatever the productions are there, productions are arranging here. So now we'll focus how to arrange the productions in this way. Okay, right. LL1 table construction. The size of the table is very simple. Whenever a grammar is given, all the rows equal to non-terminals. Number of rows equal to non-terminals, and number of columns equal to terminal plus dollar. Terminal plus dollar. So this is the size of the table. Size of the table looks like this. Non-terminals considered as rows, terminal plus dollars considered as columns. So this is what our total structure of the parsing table. Right. So let us see the way of construction of parsing tables for the given grammar productions. So we have an example grammar here. Just look at the grammar, how many productions identify. We need to construct LL1 parsing table. Construct LL1 parsing table for given grammar. Here, the grammar is having 7 productions. So 1, 2, 3, 4, 5, 6, 7. Total 7 productions are given. So this is the grammar which is given. Now we have to construct the parsing table, because to perform LL1 parsing table, the first thing and first and foremost thing required is we need to construct the table structure. Okay, right. So here, to construct the parsing table, what we need to do is calculate first set and follow set. So whatever we learned in the last class, in our last class, we learned about how to compute first set and follow set. Same, this today's class is completely based on the previous concepts. So in our last class, lecture number 3, if anybody missed that, just go there, and we solved so many questions on first set and follow set calculation. From a given grammar productions, how to compute first set values, how to compute follow set values. All these things we discussed in the last lecture. Please go through that once. Right. Now let us compute, because the construction of table also depends on first and follow set. Let us try to compute the first set and follow set values of each of these grammar productions. So try with this. What is first of C? B comma epsilon, A epsilon, AB. First of S is A. And follow. Similarly, compute the follow of everything. First follow is known thing. I think I need not to repeat this once again. No need to repeat this one. That's why I'm not repeating how to compute the first and follows of these things. Now follow. Follow of starting symbol is dollar. Like this. Follow of remaining things. If you compute, we are getting these values. So follow of AB dollar. Follow of B dollar. Follow of C dollar. These are the first and follow values. To design the table, to design parsing table, main required important thing is first set, follow set, calculation. We should have enough knowledge on how to compute first set and follow set. Most of the times we are getting questions in the GATE exam from the computation of first set, follow set. So for 2 marks, we have so many questions. In 2024 GATE, last year GATE also, we have first set, follow set computations. Right. Okay then. First set, follow set computation based on the last lecture, lecture number 3, we have computed. Then let us go for the table construction. This is our structure of the LL1 parsing table. The LL1 parsing table structure is, take all the non-terminals as rows. What is the terminals of this grammar? Number of terminals of this grammar is nothing but, non-terminals are 4, S, A, B, C. Terminals nothing but A, B, A comma B. So terminals plus dollar as columns. Like this, arrange this in a matrix format. Arrange in matrix format. Now let us see how to fill this. Table construction is a algorithmic approach. We have a standardized procedure, standard approach to construct these tables. Let us, here the construction of table is nothing but arrange these productions in these boxes, in these rows and columns. That's all. So how to arrange? Very simple. If we have any production, take all the productions one by one. If we have this production, every production, the rows and columns will be calculated in this way. Assume we have this production. This is a production. For this corresponding production, the row is nothing but non-terminal. How to identify the column? Column is nothing but first of the right hand side part. First calculation of its right hand side part. That is nothing but column is nothing but first of RHS of grammar production. So that is nothing but first calculation of ABC. This is the way columns are defined. So what is first of ABC? A here. That's why corresponding to every production, we need to identify its row and its column. The row of this will be non-terminal, so S. Column of this will be this one, A. So we have to place this production, placing the production, that's all. Row S and column A, that's all, like this. So corresponding to every production, identify its row and column, place in that position. For every production, what is its row, what is its column, identify. Row is nothing but non-terminal. So row is nothing but non-terminal and column is nothing but first of right hand side. If whenever we have this one like this. Epsilons are there, it is different. I'll explain that one also. So now come to this one. Construction of the table. So let us place the first production in its proper position. Its row is non-terminal, yes. So row position is this one, and its column position is right hand side first. So first of this part, that is A, column is A. So we are arranging this production in this place. Right. So this first production is placed in the table in its proper place. Now come to the second production. This is our second production and this is our third production. So let us take the second production. So second production, its row is left hand side non-terminal. So A, its column is first of A. First of A is nothing but A. So column will be this one. So we have to arrange this production in row A, column this. Row is nothing but non-terminal. For every production, its non-terminal becomes as row. If you want to arrange these productions in this table, the table is rows and columns. It is in matrix format. We need to identify what is the row. Row is nothing but row is equal to non-terminal of that production. Column is nothing but calculation of first set on the right hand side part. Is it clear? Because if you want to perform LL1 parsing, the production should be arranged in this way in order to make a predictive parsing table. Right. Next, if you have a production, we have production, this one, third production. This is a third production. Can you identify what is the row? How to identify row for this production? The row for any particular production is nothing but that production is non-terminal. Whatever the left hand side non-terminal is there, that production's left hand side non-terminal becomes the equivalent row, the defining row. So the row of this one will be left hand side non-terminal A. And column will be decided as right hand side first. So column of this one, will be first of double B. That is nothing but B. So we have to arrange this production. Yes, we have to arrange this production as row as capital A, column as small b. So this is the place where this production will be arranged. Right? Similarly, come to we have a fourth production, fifth production. Can you tell me to place the fourth production in this table, what should be my row? In which row it has to be placed? The rows are defined with non-terminal. So left hand side non-terminal, whatever is there, B, that should become my row to place this production. Can you tell me what will be the column? What will be the column? This is just rows and columns concept. The column is column of this one will be identified by calculating first of right hand side. First of A, that will be A. So this will be placed in row A, column B in this box. So this will be here. In this process, okay, next one is B to epsilon. The row for this will be B, then column is nothing but first of epsilon. First of epsilon. Wherever you get epsilon, in order to decide columns, whenever you get epsilon, then we need the help of follow. in order to decide the column, whenever we are getting epsilon, then go for follow of left hand side non-terminal, follow of capital B, follow of capital B to decide about columns. Is it clear? Otherwise, follow calculations generally not required. If epsilons are not there, follow calculation is not required. Whenever we are deciding about columns from the right hand side, wherever you are getting epsilon, for that place, we need to take the help of follow set in order to identify this one. So what is follow of B? We have computed already. What is follow of B? B and dollar. B and dollar. So in order to place this production B to epsilon, in order to place this production B to epsilon, here we have B and dollar, right? So the column will be decided follow of B, that is, so in row B, column B and column dollar place, we have to give B gives epsilon production. So the epsilon production is going in two places. Is it clear, this one? So whenever I am trying to place this in the table, this production, I need to identify its column. Row is very easy, non-terminal. Whenever I am identifying its column, for that, if I am getting epsilon, if epsilon is there, then in order to decide about columns, we need to compute its follow calculation. So follow of left hand side non-terminal, follow of B. That's why whenever in the first calculation time, if we have epsilon, for that case we have to go for the follow of the non-terminal to decide about columns, right? So B gives epsilon is coming in the two places because of its follow. Similarly, let us try to place the C productions also in the table. C is having two productions, C to B. So this is very easy. Row is C, right hand side first, C gives B. So first of this is B. So the column will be decided based on first of this. Similarly, all of you please try to identify in which column position C to epsilon will be placed. In which column position C to epsilon. So this production C gives epsilon, whatever is there, C derives epsilon. In order to place this in the table, we need to identify rows and columns. Row is non-terminal C, that's why row is clearly there. What about column here? The column will be identified based on right hand side first. So first of epsilon, whenever we are getting epsilon, then take follow of C. Follow of capital C is used in order to identify the columns of that one. So follow of capital C. What is follow of capital C? That is simply dollar. So C gives epsilon will be placed only in the dollar position. Okay. Like this, placing of all the productions are happened here. We have arranged all these productions in its proper positions. So arranging of all these things in the proper positions is called as construction of LL1 parsing table. So this is the corresponding LL1 parsing table for the given grammar productions. Anywhere, any doubts in the construction of this one? So it seems to be simply placing productions in their corresponding rows and columns. That's all, nothing will be there. So table construction is simply placing of every production in its corresponding position of the table. This table, whatever is table is nothing but arrangement of all these productions in their proper positions. All the remaining cells we'll keep it as empty. We'll just leave them as empty. These things just you just remember this as empty. In the algorithm running time, whenever we have these situations, these will produce syntax errors. So whenever we are running the algorithm, if we have these empty cells, any empty cell situation encounters, that produces syntax error. Okay. So this is the concept of construction of parsing table, LL1 parsing table. Any doubts in the construction part? Any doubts in the construction part? So we have so many questions in the GATE exam, like this. Sometimes they may ask you, what is the table entry, LL1 parsing table entry on beyond dollar? Which production is there on beyond dollar? And table entry, which production is there on C on dollar? Like this. These questions are common questions, so many times asked in GATE paper from the table construction part. He will not ask you to construct total thing. He will ask you to just to identify some particular cells. What is this cell? Beyond dollar cell entry, is there any entry on this or not? Is there any entry on this or not? He will mark some x1 here, x2 here. What are the values of x1 and s2? Like this, these general type of questions many times asked in the previous papers. Okay, right. Let us try to construct one more question, which is a GATE question. So for this, construct LL1 parsing table for the given grammar. For every grammar, no need to compute first and follows every time. First set, follow set, competition for all the things, no need. If you are computing, that would be better. Okay. So better to compute first of s, follow of s for all these grammars for initially. Then we'll try to construct the parsing table. Let me take this information, first set, follow set of this. Just have 3 non-terminals here. First set information, follow set information. If you compute initially, it would be better. Otherwise, whenever is required, that non-terminal information you compute. So first of is AB epsilon. First of capital A, AB epsilon. If you want to know how to compute this properly, you can just watch lecture number 3. I have explained clearly how to compute by using the rules. Lecture number 3. Fall of S is AB dollar. Fall of A, AB. Fall of B is AB dollar. I am not explaining you once again how to compute this because we already studied that lecture. So first follow computation of every non-terminal is done like this. Now by using this information, let us try to arrange this in their proper places. So productions, we have 5 productions here. We have total 5 productions. So placing these 5 productions in this table in their respective positions, that is what the table construction. So let us go to the first one. Where to place the first production? It's very easy. Corresponding to everything, calculate row. The row for this is S. Column for this is right hand side first. First of this. What is this first of this part? First of this is nothing but A. So column will be decided as A. So the table entry for this production, row is this, column is this. First production, row is S, the first of this part is A. That's why column of first of this part is A, column is A. So the table entry for this is this one. Then second production, the row of this one will be S, column of this one will be right side first of this part, that is B. So column is nothing but B, row is S, column is B. So second production will be placed in, okay, right. Now third production, S to epsilon. The row equal to this one is S, row is already there, column. The column of this one is equal to first of this part, that is epsilon. Whenever we are getting epsilon, we have to go for fall of S. Fall of S. So based on this, in which column positions we have to place this S gives epsilon production, third production, in how many places we have to give the third production? Can you please answer this one? Can you please try from your end? What are the positions of S gives epsilon production? Column positions of S gives epsilon. In which column positions we can arrange this production? That is fall of S. So fall of S also we have computed. What is fall of S? AB dollar. So here the columns of this is AB dollar, AB dollar. That's why epsilon production will be placed in column A position, epsilon is placed in column B position, epsilon is placed in column dollar position. So this third production is going to place in three places in the parsing table. That's why the entries of parsing table may be, sometimes it may be multiple entries. If multiple entries comes, what happens, that we will see. Okay, right. So this is the position of third one. The same way, let us try to compute fourth production, A gives S. So the row for this will be here, column of this one will be first of S, right side first of S is AB dollar, so AB epsilon. Look at this, first of S, AB epsilon. So for A position we have to give this. Look at the way of placing. Column is already decided. A position we have to place this, B position we have to place this production. And for every epsilon, whenever epsilon is there, for epsilon again we need to calculate fall of. Whenever we have epsilon, for this calculate fall of A. What is fall of A? Fall of A is AB. AB. A comma B. So A gives S production. Again we have to give in A gives S. It is already there in the A place. It is already given. B place. It is already there. So same production writing multiple times is meaningless. That's why A position, B position already there. So the fourth production, A gives S goes in the two places. That is column A place as well as column B place. Last one, fifth production, B to S. Same thing, the row for this is B, known thing. The column how to decide? Based on first of S. First of S is AB epsilon. So A place, column A place, we have to give this production. Column B place, we have to give this production. Whenever we have epsilon, for this, compute fall of B. What is fall of B? Fall of B is AB dollar. AB dollar. So this production we have to give in A position, which is already there, in B position, which is already there, dollar position not there, dollar position. Okay, so this is the LL1 parsing table. This is the LL1 parsing table corresponding to the given grammar production. So deciding columns, the rows are very simple. Whenever a production is there, we have to place the production in the table. Table is nothing but it's a matrix format, combination of rows and columns. So for every production, you have to decide what is a row, what is a column. Deciding row is very simple. It's left hand side non-terminal. Column, the deciding column is right hand side first calculation. In the right hand side first calculation, if you have a epsilon, then take the follow value of that non-terminal in order to decide about columns. If epsilons are not there, no need to go for the follows. Okay. So this is the way table will be constructed. Okay. Right. Here in this table, we have some observations. Whenever we compare the previous table and this one, there are some observations. Observations are like this. This parsing table contains multiple entries. In one cell, multiple productions are there. One cell contains multiple productions. A to S is not in epsilon because the follow value of A does not contain epsilon, dollar. See here, if anybody having doubt, I am computing this once again. A gives S. So here to decide about column, first of S, that is A, B, epsilon. Look at once again how I am computing. A, B, epsilon. A place, we have to place this production, column A place. And we have B value also. Column B value also we have to place this production. And due to this epsilon, we have to calculate follow of A. What is follow of A? What is follow of A here? Follow of A is just AB only. Dollar is not included. Someone is asking this doubt that why we don't have A to S in the dollar position, because follow of A having A comma B. So we have to place this production A place, which is already there, and B place, which is already there. So dollar is not coming here. That's why I'm not placing this one here. Right. Now we have a something called as LL1 grammars. Grammar is called like ambiguous grammars, unambiguous grammars. We have LL1 grammar. How to know whether a given grammar is LL1 grammar or not? Any grammars, LL1 parsing table in which at least one cell having more than one productions, in any cell more than one production you observed, the grammar is not LL1 grammar. Every cell contains only one production, multiple productions not present in any of the cell, the grammar is LL1 grammar. So here we have two tables we constructed. This is one of the table. Observe this table. One cell having only one production, one cell. So the cell of the LL1 parsing table should contain at most one production. If it is not there, no problem. There, exactly one. Multiple productions not allowed. If allowed, the grammars are called as not LL1 grammars. That's why if you want to name these grammars, this grammar name is LL1 grammar. The name of this grammar is called, this is a common question we can expect. This grammar name is called as LL1 grammar. Whereas the previous table, whatever we constructed, for this, if you want to name this, name of this grammar is not LL1 grammar. Like this. Based on the tables, based on whether a table contains multiple productions or single production corresponding to any cell, based on the number of productions in a cell, particular cell, we can give names LL1 grammars, not LL1 grammars. So not LL1 grammars are like this, LL1 grammars are like previous things. Okay, so this is a common question. There are so many questions of this type in previous paper. Which of the following grammar is LL1? Okay, this is a table based construction is one way, and without tables also we can construct. I will tell you the rules. So LL1 grammar detection, ambiguous grammar, all these things are not LL1s. All these are not LL1 grammars. If a grammar is LL1, if a grammar is ambiguous, not LL1. Grammar having left recursion, not LL1. Not left factored, not LL1. So all these are some of the grammars which are not LL1 grammars. Okay, so like this. What are these LL1 grammars? LL1 grammars are grammars which are suitable for LL1 parsing. Multiple production tables are not suitable for the algorithm. That's why single production in every cell. Each cell contains, if production is there, it should be single. So these type of tables only used. That's why these type of grammars are called as LL1 grammars. So that is what about LL1 table constructions. I hope in today's class we discussed about which type of grammars comes under LL1 grammars, how to construct LL1 parsing tables. So LL1 table construction is very easy concept. That is simply based on first set follow set calculations. So once the first set follow set calculations are comfortable, then the construction of table is just identifying rows and columns and placing the productions in the corresponding row and column. Okay, so that's all about the table construction for today's lecture. Any doubts from your side, you can please ask me from this table construction. In tomorrow's session, we can come with some other new concept. Okay, we'll learn about parsing. Tomorrow also we are learning about concept of parsing. Parsing is going on. So in the parsing, some other concept, way of designing parser with the help of some other concept. Okay. Okay guys, that's all about today's class. Thank you all. We'll see in the next class with some other concept.